Welcome to Module 1, Lesson 1 for 4th grade. Our I can statement today is I can use a place value chart to compare the values of different digits and justify the comparisons. So we know in reading this that we're going to be referencing a place value chart, and we're going to be comparing the different digits within a number. We also see this word justify, so we're going to learn what it means to justify those comparisons we make. We'll use data from our place value chart and other tools to justify those comparisons. So we're going to start on page 6 with our build understanding problem. The problem states, the museum has 11,100 butterfly specimens. Describe the relationship between the values of the digits in the thousands place and the hundreds place in 11,100. Here it asks us to represent and describe 10,000s, thousands, hundreds, tens, and ones. Over here, it's showing you examples of what base 10 blocks would look like. If you have these at your house, you can go ahead and get them out and use them to represent, or you can use this space to draw a representation. So you can also see down here, it gives us a visual of how we could draw this. Right, the tiny little circle would be our 1, this line would be our 10, and this square being our hundreds. In my representation, I'm going to start like a place value chart with my smallest place value being over here to the right and increasing as I move to the left. So I'm going to start that representation with the ones. Right, so we know that we can use that like those tiny little ones cubes that you guys have used. So this is worth 1. The next place value that we would look at then is our tens place. We know there are 10 ones in one 10. So we're going to represent that with our little stick here, showing that this is worth 10. And then when we think about 100, we know there are 10 tens in 100. So we can go ahead and show that as one of our flats, the 100. Okay, so those are the 3 that it's given us down here. After our hundreds place, we move into the thousands place. You guys can see right here, there's an example of those thousands cubes that you sometimes have when you're in school, or you might have them at home as well. We can show this, right? We can keep our 100, and we know there's 10 of them. So we can show this as a cube. The easiest way to show a cube is just to give us some little diagonal lines here so that it looks three-dimensional. And we know that's worth 1,000. Now here's what's going to get a little tricky. We need to represent these 10 thousands. Well, in the name we hear that 10 thousands is 10 thousands. So just like we did for our ones and tens, we basically made a stick out of those ones cubes. We're going to do something very similar with our thousands. Right? We're going to create 10 of these thousands. So I'm going to go ahead and just draw a really long stick for this and break that apart. They're not going to be perfectly proportional, but we're going to show 10 of them. And again, just like we did to show our cube, to show this is three-dimensional, that there are a whole lot of thousands here, right? This is 10 thousands stacked up tall. So there's our representation. Go ahead and pause if you need a little bit more time to draw that. And now we move on to this question set here. It asks us, well, why did we use each representation? What this question is asking us is, how did we come up with our method? Why did we have one smaller than a 10? why is 100 greater than a 10 stick? So go ahead and answer in the way that makes the most sense to you. An example for this answer might be that our hundreds flat is made of 10 of our tens. So we look at question B. What do you notice about the size of each representation? Well, as we moved, I'm going to go back to my picture, right? We started with a smaller one, then it got taller, then wider, and then it got like three-dimensional, right? We moved backwards. So as this is happening, and then when we get to the 10,000s, it gets even taller again. What's happening each time? Well, each representation is getting greater, and it's getting greater by what same amount, right? We had 1, then 10, 10, then 100, 100, then 1,000. It's increasing 10 times as we move up. So each representation is 10 times the size of the previous one. Letter C asks us to describe the relationship between the values of the digits in the thousands place and the hundreds place in 11,100. First, I want you to go ahead and underline the digit in the thousands place and circle the digit in the hundreds place. So we're underlining the digit in the thousands place, circling the digit in the hundreds place. Well, both digits are 1. So what's the relationship between the 1 in the thousands place and the 1 in the hundreds place? Well, the digit in the thousands place is 10 times greater than the digit in the hundreds place, right? So this 1,000 is 10 times greater than that 100. So go ahead and write your answer. Question number 2. As many as 136,080 insect fragments could be found in the foods you buy at the grocery store. This means you might be eating bugs. What is the value of each digit in the number 136,080? The value of each digit depends on its place value position. A place value chart can help you understand the value of each digit in a number. Now remember, our I can statement was that we were going to be able to use a place value chart. So we know right away this was part of our I can. We can take a look over here at our vocabulary to find that definition of place value, which means it describes the value of a digit in a number. Each group of the 3 digits in a multi-digit number separated by commas or spaces is called a period. Each period has hundreds, tens, and ones, so we can see that represented here in this place value chart. We need to go ahead and write the digits for 136,080 in the top row, this section here of the place value chart. Go ahead and pause the video and fill those in. Okay, so go ahead and check and see if you've gotten that correct. Then we're going to go ahead and move on to the second section of this page with the questions. A is asking us, what is the place value position of the digit 6? So looking back at our place value chart, we see this digit 6 is in the ones, but the ones of the period for thousands. So 6 is in the place value of the thousands place. How can you find the value of the digit 1? So we need to look at here and find our digit 1. The digit 1 is here. We can use our place value chart to find that that digit is in the hundred thousands place. So the value of that digit would be 100,000. Letter C is asking us to go back and fill in that bottom half of the place value chart. So it's giving us different ways to look at each of these place values. You can see here it gives us 100,000. Then it's asking us how many 10,000s. Well, we see our 3 here, so we know this value is 3,000s. Next, we have our digit of 6, which is in the 1,000s place. So we know that value is 6,000s. Go ahead and complete the rest of this row. All right, go ahead and check your work. Okay, then we're going to write that value out in standard form. So here we have 3 10,000s is equal to 30,000s. 100,000 is equal to 100,000. 6,000s, 0 hundreds, and 0 ones. So now we can go ahead and answer letter D. What do you notice about the value of each place in the place value chart? So if we're looking down here, our digits are not the same like they were in that last problem. But as we move across our place value chart, each place value is still increasing 10 times the value. So we can answer the value of each place is 10 times the value of the place to its right. So the value of each place is 10 times the value of the place to its right.